Have you ever stopped to think about the difference between just moving and moving in a specific direction? Well, that simple idea is right at the heart of one of the most fundamental concepts in all of physics: scalars and vectors. And as you're about to see, getting this one thing down can honestly change how you see the world around you. So let's just kick things off with a question. Is there really a difference between saying I walked 3 kilometers and I walked 3 kilometers east? I know, it might seem like a tiny detail, but stick with me, because by the end of this, you'll see exactly why that difference is actually huge. Now, to answer that, we actually need to zoom out just a little bit. Before we can get into the nitty-gritty of scalars and vectors, we've got to talk about the bigger group that they both belong to, and that group is called physical quantities. So what is a physical quantity? It's really simple. It's anything in physics that we can measure. If you can put a number on it, like how long this room is, how much time has passed, or how fast a car is going, then you're talking about a physical quantity. Now, here is the really cool, beautifully simple part. Every single one of these measurable things in the entire universe falls into just one of 2 categories. That's it. It's either a scalar or it's a vector. So let's start with the first and, honestly, the simplest of those 2 categories, scalars. The funny thing is, you actually use these all the time, probably without even thinking about it. Okay, so what exactly is a scalar? It's any measurement that is completely described by its magnitude. And magnitude is just a bit of a fancy word for its size or a number. A scalar only tells you how much of something there is. That's it. There's no direction involved whatsoever. Just think about it for a second. When you say the temperature is 30 degrees, or that you weigh 60 kilograms, or that you waited for 5 minutes, you've given all the information anyone needs, right? You don't say it's 30 degrees upwards, or I waited 5 minutes to the left. They're just numbers, and that's what makes them scalars. All right, so scalars are pretty straightforward. They're just a number. But what about that other category? Because this is where things start to get really interesting. Vectors? Well, they take that simple number and add one crucial, game-changing piece of information. A vector is a quantity that needs 2 things to be fully understood. It needs its magnitude, which tells us how much, and it needs a direction, which tells us which way. If you don't have the direction, the information is basically incomplete. Think of it like this. Saying you moved 10 meters, well, that's just a distance. That's a scalar. But saying you moved 10 meters times forward, now that's a vector. A car's speed might be 60 kilometers per hour, but its velocity is 60 kilometers per hour to the east. It's that simple addition of which way that makes all the difference. To really nail this down, let's check out a quick story with 2 friends, Ali and Ahmed. Imagine they both go for a walk. Okay, so first, Ali comes back. He says, I walked 3 kilometers. Simple enough. It's a clear statement about the distance he covered. And then Ahmed comes back, and he says, I walked 3 kilometers to the east. See that? His statement has that one little extra piece of information. And this is just a perfect illustration of the core difference. Ali described a scalar quantity. We just call it distance. We know how far he went, but we have no idea where. But Ahmed described a vector quantity, which physicists call displacement. We know exactly how far he went and in which specific direction. This table here really just breaks it all down nice and neat. For a scalar, like mass or time, direction is totally irrelevant. It doesn't even make sense. But for a vector, like force or velocity, that direction is absolutely essential. I mean, pushing on a door with a certain amount of force doesn't mean anything until you know which way you're pushing it. So look, here's the ultimate rule. It all comes down to one really simple test. When you're looking at any physical quantity, just ask yourself this one question. Is a direction either specified or needed? If the answer is yes, boom, it's a vector. If it's no, it's a scalar. It really is that easy.
All right, you've seen the rules, you've seen the examples. So let's do a little pop quiz right now to see if you've got it down.
Okay, first question. Let's talk about the speed of a car. What do you think? Is it a scalar or is it a vector? If you said scalar, you are 100% right. Speed, like 100 kilometers per hour, it just tells you how fast you're going. It says nothing about where you're going. Okay, nice work on that one. So what about its close cousin, velocity? Is that one a scalar or a vector? You got it. Velocity is a classic textbook vector. It's just speed plus a direction. So 100 kilometers per hour north isn't just a speed anymore, it's a velocity. You absolutely need both of those pieces of info for the full picture. So, when you boil it all down, it's this simple. Every single measurement in our physical world is either a scalar, which is just a number, or a vector, which is a number and a direction. And the one single thing that separates them is that one crucial detail: which way? So, I'll just leave you with this one final thought to chew on. Now that you know the difference, what's a vector that you use every single day, maybe without even realizing it? Once you start looking for them, you'll start seeing them absolutely everywhere. Thanks so much for joining me for this explainer.